Hello and welcome back to Calculus 2, section 6.4, shell method. So what we studied earlier is the disk method, also washer method, and we know that we cut in a way to get disks. So if I had, let's say, a cylinder, right, there's an x-axis there with the rotation, right, and all that. So if I cut this way and take the piece out, it's going to be a disk. So it was called the disk method. If it had a hole inside, it was called the washer because material was on the outside and there was a hole in the middle. Now I'm going to take the same cylinder and instead of cutting it, it still rotates on X, right, to create the cylinder. But instead of cutting it vertically, I'm going to cut it horizontally. So the cuts are gonna come in like this. Now that creates shells, right? So think about it. If I cut this way, I'm getting disks, right? If I cut this way, I have a disk. But if I cut this way, right? I cut off the piece, I have a shell. I cut off another piece, I have another shell and another shell, seashells, right? So that's what's called the shell method, because the pieces that you get are shells. So shell method cuts 90 degrees to what the disk method used to cut. It's called the shell method because we are getting shells in shape. So how does this work? The textbook offers a formula which you put on your class prep and understood hopefully. I learned the more advanced version of the formula, which in my head makes more sense because it uses applied words rather than this is the formula, plug stuff in and walk away. You are welcome to use either of the two as long as you get the correct answer at the end. I don't care which formula you used and which way you remembered how to do this stuff. So the formula in the textbook says that the volume is 2 pi integral a to b of x f of x dx for rotation on y. And it's 2 pi c to d of y f of y dy for rotation on x. So that's the textbook. And it's pretty straightforward. But unfortunately, this type of a formula excludes the whole family of the problems that you might get. And you have to pull off some serious witchcraft to do them using these forms. I offer you more powerful version from a different textbook where I learned calculus from. And that one says that the volume is equal to 2 pi integral a to b p of x h of x dx for rotation on y. And the same thing, v equals 2 pi integral c to d for p of y h of y dy for rotation on x. Now these are my preferred formulas, but you can use the other ones if you want. P stands for position, and h stands for height. Now, for majority of these problems, this position is x or y, just like the formulas here suggest. And then this h of x and h of y are sometimes these f of x and f of y. But then you can also have an object with a hole, something similar to a washer method, which that doesn't cover. It also doesn't cover if the axis of rotation is away from x and y axis. And at that point, these formulas become far more powerful than the formulas up there. So what I first want to do is solve a very basic problem using disk and shell method, and then discuss the differences between the two. These methods are not competing with each other. They actually complement each other. Certain problems will be easy using both methods. Some problems will be faster with one method than the other, and some problems will be impossible to do with one of the methods, and you can only use the other one. So sometimes the only way you can do a problem is a disk method. Sometimes the only way you can solve a problem is a shell method. Sometimes you can use both. Sometimes one is faster than the other. So that's going to be, again, experience and the number of problems and the amount of homework you guys do to see all of those, and especially to see before you start working on a problem. If you are masters of dx, dy rectangles, you will be able to set these things up like this and figure out which method is better and how it works. No coffee. So, he knows the rules, he just doesn't care. All right. So, simple problem. We are going to rotate the triangle. Two to 4. And I'm going to rotate that on the x-axis. And I'm going to use both methods for this. Now, first is the disk, because that's the one we already know. Get it over quick. V equals pi integral 0 to 4, and then function over here is negative 1/2 x plus 2 squared dx. So it's that linear line. You know that the slope is 2 down, 4 over, so 2 divided by 4 is 1/2. It's negative because it's falling. And then it has the y-intercept at 2. So plus 2. So FOIL, solve real quick. Pi 0 to 4. When I square this, I get 1/4 x squared minus 2x plus 4, and then we integrate. That will be 1/8, no, lie, 1/12 x cubed minus x squared plus 4x from 0 to 4. Who picked these numbers? And then we compute. We don't have to calculate at 0. So I have 4 cubed over 12 minus 4 squared plus 4 times 4. Oh, perfect. Amazing. So these two die because it's 16 minus 16. 4 has a 4 to cancel with 12, so it's 16 over 3. So 16 pi over 3. What happened? Good. So now we're going to do the same problem using the new method called the shell method. So the shell method says 2 pi, but then hold on. We have rotation on x. Rotation on x calls for a y integral, right? So my limits are 0 to 2. Awesome. Y, and then I am using dy, right? So I have to flip the function. Function used to be y equals negative 1/2 x plus 2. So now that's y minus 2 is equal to negative 1/2 x, and then times negative 2 is negative 2 y plus 4. So that one. So this is going to be, I'll explain later, your position, and this is over here the height. And here is the first crash. So that's our position, and that's our height. Yeah, that's what I said. Please pay attention. So now 2 pi integral 0 to 2 of 4y minus 2y squared dy to integrate, and we better get 16 pi because we are solving the same problem just a different way. So when it starts crashing, then it keeps crashing.
Hey Professor, before you even integrate, you can factor a 2 out of that, can't you? Make life a little easier?
Yep.
I think that would be 4 pi.
Mm-hmm. If that's gonna make you feel better, here 4 pi kicked out. Then integral of 2y is just gonna be y squared. Oh, that's nice. Minus y cubed over 3 from 0 to 2. Actually, I like it because it gave us easier, nicer values. 4 pi, and then I get 4 minus 8/3. And then we don't worry about zeros. So that's 12, that's 4, 16/3. Nice. Awesome. When you do the common denominator, this is 12. 12 minus 8 is 4. 4 times 4 is 16 pi over common denominator was 3. Okay. So we see that we used both methods to obtain the same value, except disk method was doing dx while the shell method did dy. And that's the difference between the two methods. For the disk method, the cut is perpendicular to the axis of rotation. For shell method, cut is parallel to the axis of rotation. I want to work out another shell problem before we continue talking about the differences. So let's practice a little bit more. So let me see which problem would be good. So rotate around y-axis. This is how I say y rotation, right? Y and then rotation. Problem number 12 says y equals square root of x. Y equals 0 and x equals 1. We always draw first. So we see the region and we know how to set it up. And I'm going to use the rectangle, guys. So let's draw this. Here's the square root. Rotation is on y. And then I have y equals 0, which is x-axis, and x equals 1. So let's say that's x equals 1. I'm rotating this piece around y-axis. What does that mean? That means that that piece will be on the other side like this, and then it will have right shape. So this is some weird shape, right? Rotates around y. So shell method here, if you have rotation on y, that means we are using dx. That is the part that you have to learn. When I go back to formulas, whether you're going to use the textbook or what I gave you, observe. Y rotation, dx. X rotation, dy. Disk method has them in order. Rotation on x, dx, rotation on y, dy. This one has them swapped. That's why we have a different method. If they were the same, then we don't need two methods. So I'm using shell method, and I'm going to rotate on rotation is on y, so I'm using dx. Volume is 2 pi integral 0 to 1. And now here is the dx. What's the position? Position is this much over there. And you see that that's measured by x. So that's why we put x for p of x. And the height of the dx rectangle is square root of x minus 0, because it's the bottom, right? Bottom is 0. So you can just put square root of x and then dx. So that's why the other method, the other formulas I said in the textbook were inefficient, because they don't allow for that top minus bottom if you had a little bit weird shape, right? Because you can have a weird shape there. You can have a square root going this way and x squared going that way, and then that rotating around. It's a top minus bottom. And then your age is f minus g. So those formulas that I gave you allow for a situation like this. Anyway, we'll see that later. So I put this minus 0 there just because I can, but I don't need it. So what do I have? I have 2 pi integral 0 to 1 of x to the 3/2 dx. Because root x is 1/2, so 1/2 plus 1 is 3/2. And now we integrate. Copy 2 pi. Integral over there is x to the 5/2 over 5/2 from 0 to 1. And that gives us 4 pi over 5 times 1 to the 5/2 minus 0 to the 5/2. So the whole thing is just 4 pi over 5. So the shell method is, if you rotate on y, you use dx. If you rotate on x, you use dy. Make sure you study those formulas closely to catch those differences. Next, will this problem be possible to work out using disk method? The answer is yes. You have to use dy because rotation is on y. For disk method, if you have rotation on y, you have to use dy. But look at your dy. Your dy would be this way, which means you are using washer method, right? That's more work. You are squaring two different functions. There is a function x equals 1, and then the function over here, x equals y squared. So you would have to do 1 minus y to the 4th dy, and then work it out from there. You have to get the same answer. It is possible to do this method because we were able to flip these functions around. So it's possible to do that method. If we if we are not able to flip the functions, then the other method cannot be done. Not every function has the inverse function. So you have to be mindful of that. If you are rotating certain shapes, one method might not be possible. That all depends on the way you rotate, the ways the functions are. Maybe take a look at another problem just for, something for you to enjoy. I know how much you love this. Easy. Problem 14, nothing to worry about. It says y is equal to square root of 4 minus 2x squared. Y equals 0, x equals 0. Rotation is on y. First quadrant. What is the graph of that? Anyone? What is this? Just tell me what it is. Nope. It's not a function, I'll help you that much. You are close. It's not a circle. It's an ellipse. It's a half ellipse. You know how you know it's not a circle? The values in front of y squared and x squared are not the same. That's why it's an ellipse. If the value, anytime numbers in front of x squared and y squared are the same, it's a circle. Every time they're different, it's ellipse. So when you move square on the other side, you get over here. To graph this, you move the square root becomes a square on y. So this is 2x squared plus y squared equals to 4. You divide everywhere by 4 to get 1, and you get x squared over 2 plus y squared over 4 is equal to 1. This is ellipse, and it's just the first quadrant of the ellipse. So the radius on x is root 2, radius on y is 2. So if we are graphing this, radius on x is root 2, that's about 1.5. It's 1.4 blah. And then this one is 2. So that's how it looks like. And then they said first quadrant, which is when I grab the eraser and I erase all other quadrants, because they said first quadrant. So I just get rid of everything else. And
Wait, will you still be able to graph it even though you realize it ain't in left?
what do you mean?
Be able to still find, can you still graph it the normal way where you plug in numbers and...
Yes, yeah, that always works. It's time consuming, but it always works. Yes.
Okay.
You pick x's and compute y's. Yes. We are rotating on y, which means we are using dx, which means we draw dx, and then we set this up. The volume using shell is 2 pi integral. We know it's 0 to root 2. Right? We know that now because it's ellipse and that's the radius. Right? In x direction and radius in y direction. So 0 to root 2 of x times 4 minus 2x squared dx. How do we integrate this, my Calc1 gurus? Yes.
Use substitution.
Use substitution. Very good. Let's go. While we're still young. Use sub. We got 17 seconds.
No, I meant like the x value, trying to figure out what the zero values are between the interval, because if you graph it or you did something different, when I try and solve them out by myself, they the same numbers which the graph shows.
Now that's 0, which doesn't make sense.
It's gonna
Do on Thursday, actually 14th.
I'm saying I'll never pass that. Just rolling out the square root.
Smile, look at it. Look at that smiling.
I wouldn't trust
That
you.
kid was like,
No, but it's still smiling.
but that kid was way smart to get 100 and everything like me.
We'll see. I'll make a custom build test. For him. Okay. U equals 4 minus 2x squared. Du equals negative 4x dx. I need negative 4, right? I like to fix rather than do it any way you want. So negative pi over 2 integral of square root of u du, and we have to change the limits now. So when you plug in 0, you get 4, and when you plug in root 2, you get 0, which is awesome because when you flip them, you lose the negative on pi over 2. Nice. See? So pi over 2, u to 3 halves over 3 halves, and then these die, 0 to 4. So I have pi over 3, 4 to 3 halves minus 0. Square root of 4 is 2, 8 pi over 3. Bueno? All right. No, yes. Of course it's cool, it's math. One more. Rotation is on x-axis. Problem 24. Your function is y equals square root of inverse sine of x. Y is the square root of pi over 2, and x equals 0.
I'm glad that wasn't really just in my head. He's like, that's disturbing for yourself just go looking at it.
We're bound to have at least 3 people in the room. So, are you freaking out? Look at this. Where's the rotation? On x. So it has to be dy. But look at the function, how it's given. It's what? Y equals, right? So what's the first order of business? square everything and make it x equals everything. In which case you are losing the inverse sign. It's just going to be sine of y squared. And you have the x and the y in front. You sub the whole problem is cosine of pi over 2 is 1 done. With 2 pi. That is. But it takes time for you to get used to tracing dx, dy, which method?
What was the pi over 2?
Okay. Perfect. Just plug it in the interval, you're done.
We're here every day. I'm sitting here on Fridays. We like to tell ourselves we don't.
That's the right answer. All right. So one more time. We have the rotation on x and the shell method. When you marry those two, you get dy. If you have dy, you have to plug in x as a function of y. But your function is y as a function of x. So you have to massage that. So we get y squared is equal to inverse sine of x. And then we apply sine to both sides to cancel off the inverse. And we get that x is equal to sine of y squared. And then from here, it's walk in a park, right? You have the volume is 2 pi integral 0 to square root of pi over 2 y sine y squared dy. You have the u sub on y squared with the y in front, fix the 2. 2 will cancel the 2 in front of pi. And the rest is 1. Keep going. That's the one from the, can you memorize the formula or yes? That's the distance from the representative rectangle from the axis of rotation. And you can exploit that one if the axis of rotation is not x-axis or y-axis. You would use, let's say rotation is on x equals 2 rather than y-axis. Then you would have, instead of having just x, you will have 2 axes to compensate for the shift. Those are some more advanced problems. So I'm more worried about you guys not seeing the washer portion than the shift.
of axis. With shift of axis, you can also kind of hack through shifting the function. You shift it. If your axis of rotation is x equals 2 rather than the y-axis, you move the entire problem 2 units, which means you just go x plus 2, it moves to the left. And then it's going to be volume the same, just different functions. So that's possible to fix easily, but what you can't fix is when you have a hole in the object, and the formula doesn't allow it. Which age does? No.
So what I just want to say here, what I got was a cosine, and I switched it to u values, and then I get like the wondering with the units purple, is it
0.
0, like minus 0 plus by 1, but it'd be pi then.
Yes, the answer is right.
Okay.
Yeah.
Right? So pi integral of sine u du from 0 to pi over 2, which will give us pi negative cosine of pi over 2 plus cosine of 0. This one dies. Cosine of 0 is 1, so pi. As I have foreseen. Great. So now the question is, which method is better? And the answer to that is, depends on the problem. As I said before, in some cases, one method is better than the other. In some cases, one method is not possible and the other is. And in some cases, the problem can be done in both ways, just like the one with the triangle that I did. Now, picking the method is going to be easy eventually with lots of practice. So I just wanted to set up some of the possible situations and then try and see what would be the good method to let's just discuss that. So say you have two linear lines. This is a very simple problem. You have two linear lines intersecting, and this is your region here. If I rotate on y-axis, which method is either better or possible or impossible? Yes. Washer method. Why? Washer implies dy, right? If rotation is on y. So if you're saying washer, that means that because rotation is on y, you have to do dy. If I draw a dy, look what happens. Two integrals. Would you agree on that? Because if the integral starts here, this side is swiping this function, which is 0, and this side is swiping that, and then here it switches the function. So I would have to, for dy, I would have to set the integral for this plus the integral for that. So two integrals.
May I ask you, I know you can actually do more than one interval. I know that you can have
But it's 2 because it's one function and then 2, right? 1, 2.
Okay.
So that's why it's 2 integrals. You can have 17 if you want to, but 2 are necessary, right? You can't have less than 2 to solve this with the washer method. So, and you can also call it disk, right? Because this one is 0. What happens with the shell? Shell cuts parallel to the axis of rotation, right? So shell is always stuck between 2 functions, one integral. So in this case, both are possible, but shell is easier because it's less work. So shell, one integral. Because rotation on y gives us dx, and if you draw dx over here, if you draw dx, you see that the bottom always rides this function, the top always rides that function, and that's why for the entire shape you only have one integral to worry about. Now all of this, guys, is going to build up very quickly with experience. So you ruin your weekend, obviously, doing these things. Well, actually, it's not ruined. You love this stuff, so it's actually pleasure. So you enjoy your weekend doing 5,000 of these problems, and everything just clicks quickly. Let's try something else. It's a bit similar problem. Rotation is on X. We're going to get a really cool shape when we rotate this. What do you reckon?
Disk. Disk.
Disk? Why disk?
Because it rotates around the x-axis, and once you can keep everything x.
Perfect. So dx would be perpendicular to this one. Top always rides here, bottom always rides here. Excellent. This is a basic disk method. What's happening with shell for this one? It will be dy. So, can I? Can't actually, yeah. So here is the problem where disk method works and the shell method is impossible to do. If you note, so disk method is just fine, shell method cannot be done at all because the shell method would require dy, and look at this dy, stretches between the same function, right? So can't be done. I know in this portion here it works, but this part of the graph is also the part of the problem, right? So you can pick and choose portions where it works and just compute there. So disk works. This is the worst works I ever worked with. There we go. Shell does not work at all. So it's not shell is worse. Shell is impossible for this configuration. Impossible. Now, all I need to do for this problem is to put rotation on y. Disk is impossible. You see that?
May I ask you basically, how can you identify with the shell? You always do like the one, and then basically back to the other problem we talked about the shell and how it went up and down. This went one. How can we tell what's the difference between this one, and how?
Well, you see how it collapses on itself,
Yeah.
right?
But this
That's
one
never
too,
allowed very close.
But this one too collapse on itself.
You can't, because this function and this function are always different functions.
Okay. Okay.
This one bends back.
Okay.
None of these bend back. There's no way to put. There's no way to put either dx or dy to touch this line twice.
Okay.
Where over here, you clearly can.
Okay.
That's the one that tells you you can or cannot. So maybe you want to write in your notes underneath that if this problem had a rotation on y, disk is impossible and shell is the only one that works. So if you swap rotation on this problem, put in rotation on y, disk is impossible, shell works. Now in the textbook, they are giving you the summary of differences between these methods. Similarities and differences. Other textbooks, in my opinion, do a better job than this, but this is the one you have, so you're stuck with it. And they group them by dx and dy. So look, the top is your washer method. Here's your disk method. Sorry, washer method and shell method. Both dx, rotation on x, rotation on y. There's your dy's, washer, shell, y, and then x rotation. So these two methods are fundamentally different because disk method has the representative rectangle perpendicular to axis of rotation. Shell method has the representative rectangle parallel to axis of rotation. If your axis of rotation is on x and you're creating a cylinder, perpendicular cut to axis of rotation is this one. And you're creating disks, like CDs. Shell method cuts parallel to the axis of rotation. If axis of rotation is this way, you are cutting that way and you're creating shells. That's why it's called shell method. So the cut will tell you which way. So try homework exercises, see, and obviously the most valuable exercises are those with their, making one compete with the other, and then wondering. So when I was studying this as a student, obviously it was confusing first time you see it, and I have no doubts that many of you are still going, what the hell? You have to understand that the learning component has to happen before you go and start hammering problems. This is Calc 2 now. Calc 1 was to some extent monkey sees, monkey do. This over here, you have choices. Is it one function? Is it two functions? Can I flip it? Which way dx goes? Especially if your Calc 1 wasn't dx, dy driven to set up integrals. If you are missing that component and if you're still going, what the hell is going on with this dx thing, the representative rectangle, in that case, all of this is going to take longer. Don't get frustrated, it takes time. With practice, with persistence, I'm here, Evan will be here, tutoring center is here, YouTube is here, right? So keep pounding on it and eventually it will just click and it will be easy. So that's the 6-4. There is nothing else in there. We're going to take a short break and then 6-5 after that. So more work.